So hi everyone. Today we'll try to understand how you can code a baseline neural network using TensorFlow for multi-label classification. So I'm assuming that you must have had some one-hand experience with binary classification or multi-classification with neural networks. So this demo is around how you can use the same for multi-level classification using TensorFlow. So let's get started. So first of all, what we will do is that we'll import TensorFlow STF. As you can see, the code snippet is very short, so don't need to worry. You need to have basic knowledge of neural networks before starting. So do keep it in before moving ahead. The second thing and that we are doing is we are first of all creating a dummy data set using make multi-level classification. So if you have a data set, I think then that's completely fine. If I demonstrate you the data set that we have created is, so here you can see there are 5 features, and then eventually you can see the labels also 1110. So it's more of a if there are 4 labels, 4 classes present, one would mean that that particular label is present in that particular sample, and zero means that that label is not present. So for example, for the first entry, the first 3 labels are available, the last label is not there. So this is how you need to reformat your data set if you have any custom data set with you. This one is a dummy data set that we have generated. Next is we are doing a train test splits. The third part is that we are designing a baseline neural network. So I think I am assuming that you basically know what a dense layer and what is a sequential model that we are building out. So here you can see that we added 3 layers: dense 64, dense 64, and dense 4. So the activation, so the most important part in this whole thing would be the last layer that we got. So before that, the previous layers, you can have anything of your choice. You can add many layers, you can add a drop off, you can add dense layers, you can play around with the hidden layers, you can play around with the activation functions. But in the lastly, you need to have a sigmoid as an activation function for multi-label, and the total number of classes that you have, 4. So in case of a multi-class classification model, if you would have been designing the same neural network, we would have changed this activation to softmax, and rest of the things would have remained the same. In case of a multi-level classification model, we are changing the softmax to sigmoid. That's the only change we need to bring in. That's it. Remaining optimizers lost. You can have anything and then call in the fit. So you can see that the fitting is started, and eventually once you're predicting for the X test, you can see that for multiple classes we are having probabilities more than 50. This means that multiple classes are getting predicted. So as you can see in the first sample, only 0.9 and 0.5 and 0.6. So if it would have been a multi-class classification problem, this would have been the probabilities would have added up to 1 for all the 4 classes. So eventually one of the classes would probability would be high, and for the rest of them would be very low. So in this way, you can create a neural network for multi-label classification, and by making just a very small change in any of your existing binary or multi-class classification model, that is the activation function, and looking at the file number of classes that you have. That's it.